Good morning, a ninth grade honors science students. This is Mr. Kivamaki. I'm speaking to you from the basement recording studio, so that's why it might sound a little bit odd, so to speak. So, anyways, we are going to be looking at the process of science inquiry today, and all science, no matter what kind it is, basically operates under the same principles. And so we are going to look at specifically today just a couple parts of it, and then we're going to extend tomorrow and look at a couple of the other aspects. So as we go through this, I expect that you'll be thinking things through and making good responses to the questions, because that's what good scientists do is they ask questions and then they try and figure things out. So let's go to this next slide and just look at what happens. And look to the middle of the circle. And that thing is called phenomenon. All science is based on people noticing things and going, well, I wonder why that is. And that's the big main thing about science. It's all about answering a question. It's not trying to memorize the periodic table. It is not learning all of the equations in physics, but it's instead learning how to observe things and then wonder about it. I wonder why that's happening. Or I wonder how I can do this. I wonder how I can make things better. And I wonder why this thing is happening. So science is based on trying to explain the world. And we're going to see a phenomenon a little bit later today, and probably in just a couple minutes, that will be our guiding inquiry for this part of learning about the process of science. So that's our middle piece. And so the middle piece is a phenomenon, and then if you go to the upper left quadrant of the circle, you can see that it begins with asking questions, and that's what we're going to do first. And then the second thing that we're going to do is we're going to try and construct an explanation. Now, I don't want you to think that you need to Google this observation of this phenomenon and try and get the answer, because that's not the point. The point of what we're doing today is to, in fact, go through the process about trying to come up with an answer. And if you just Google to get the answer, you're defeating the whole purpose of what science is all about. So you're going to try and come up with some answers so that then you can figure things out. That's what we're trying to do, is figure things out. And so please don't take that shortcut of just Googling and trying to get the answer. Then the next thing you do after you construct an explanation is carry out explanations or carry out investigations. That might give you some data. And then you are going to argue back and forth about the evidence that you have. And that's the way things work in the real live world. Now, if you look off to the right, there's some things in green, the patterns, the systems, and the cause and the effect. Those things are part of the data, and those cut across all different disciplines of science. And we'll get into more detail with those a little bit later. So now here is our phenomenon, and I wanted to pause it. And I am going to backtrack this video if I can. I think I might have to move this baby out of the way. That baby ain't cooperating, so I'm just going to let her play. All right, so there you go. There's the disappearing test tube. That's pretty stinking cool if you ask me. There it is. Poof, gone. And this is not trick photography in any way. So some liquid is being poured into the test tube and it disappears. That's pretty awesome. And I went forward when I didn't really want to. I'm just going to skip up to here and make sure that we get through all the video. So right now you're just observing, and there we go. Now, next thing that we're going to look at is asking questions. So this is what we're going to really focus on today. So now I'm going to have you in a couple minutes try and ask 3 questions, or attempt to write 3 questions. This is going to be really hard. And you might think to yourself, well, this should be easy. All I got to do is write 3 questions. Well, no, it's going to be a little bit harder than you think. So first of all, your questions have to cover three characteristics. You got to address the phenomenon. And so it has to be focused on what you were observing. So you had a test tube, there was some liquid going into it. It was visible, it disappears. Why did that happen? It should be testable. Your question has to be something that a test can be run on. And then thirdly, it should address the nature of the problem. And so I see a little dash mark that says Science Cross-Cutting Concepts. Hey, there they are on the right-hand side of the screen in green. So the science concepts, now this is going to be the hard part here. The cross-cutting concepts, there are 7 of them, cause and effect. Well, this thing is causing that thing to happen. Structure and function. Okay, well, this thing is built this way because it's going to function in this manner. So it structure and function a lot of the time is related to geology. It's related to biology, looking at how animals and plants are organized. Patterns. I'm just noticing my time. I'm at the 6-minute mark. I'm gonna go through this with less detail because I'm limited to 15 minutes on this recording. Patterns. So patterns are important, and everything that you see in the world has got patterns. Scale, proportion, and quantity is our next science cross-cutting concept. Systems and system models. When you think about what systems and system models are, it can be earth systems, it can be energy systems, it is things that operate on sort of a larger scale, and it could be a huge scale, like even up to the universe, but it could also be at the cellular level, it could be at the molecular level, the atomic level. Energy and matter. Everything has energy. Energy is the ability to do work. That's a scientific explanation about it, but matter can be converted into energy. And then the last thing is stability and change. That's also kind of related to systems and system models. So anyways, those are the cross-cutting concepts, and I went through them a little bit quicker than I wanted to. So anyways, I want you to come up with 3 questions. And then there's also, and you're going to do this on a Google form, and I'm going to be observing them during the course of the day. So 3 questions. Now, here's what you need to do. And actually, I'm going to pause this for a second. Here's the form that you're going to get to. And I'll show you in a second. I'll go back in a second to show you how you get here. So this is going to be your driving question form. And you can see the phenomena again. You've got the test tube, and oh my goodness, liquid is going into it. And then poof, it disappears. So I want you to put your name, first and last name, what hour you're in, and then there are 3 things that you are going to wonder about. I wonder, and it can be just about anything, but remember to limit yourself to addressing the phenomena, make sure that it's testable, and it needs to address the nature of the problem. So those are the 3 things that you have to do with the question. Now here's how you get to the question poll or survey. Go to Schoology, go to the Wednesday introduction folder, then the Wednesday 9-9 materials folder. Click on the link, the disappearing test tube driving question form, and complete the questions. Now there's going to be the final questions in there, and I'm going to leave that as a surprise. The 4th question, please also be thoughtful on that one. So I'm just going to pause the video. I'd like the video to be paused, and you now have some work time to get going on your questions. Be thoughtful. This is going to be hard, and that's okay. Please pause the video now until they are done with completing their Google form. Thanks. All right. Hopefully we all have some good questions. Now what we're going to do is we're going to review some of the questions that we have. So now what we have to do is do some more navigation. Just wait till the instructions are done, and you can see that they're written here, but just wait till the instructions are done. So here's what I would like you to do. You're going to go back into that same folder, the introduction folder. You're going to go to the Wednesday 9-9 materials, and then find the disappearing test tube Jamboards folder. and then click on it, and there's going to be 2 Jamboards in there, and we're going to be working on these for the rest of synchronous time and possibly maybe a little bit of asynchronous time. What I would like to have, so I want everybody to go through the first couple slides, because those give instructions on how to do things, and then I would like the EP Online students only to post your one best question on the appropriate page. And it should be pretty obvious which one it is. And I will show you that in a second, which one to post. All right, here's the first slide of the Jamboard. Hopefully you still haven't started getting there, but here's what it's going to look like. So here's the first page. Then we navigate to the second page. Here's how we navigate. It's right up here. We click on this frame, and hey, there it is. There's the phenomenon again. And then right here, EP Online students, post your best question to what do you wonder? There's your text box. There's a sticky note. So sticky notes, I think, probably works best in this situation. So those of you, I think there's about 10 to 12 of you in each class that are EP Online. Make a sticky note and put your best questions on the board. And I would like the video pause now until we get all responses. Thanks. Okay, had some technical difficulties there. Back on charge. Hey, here are some example questions that also have cross-cutting concepts listed for you. And I want you to compare the questions that you have written and the questions you have seen with these questions here. And I'd like the video paused for like a minute or so that students can read the questions. Thanks. Okay, the next thing that we're going to be doing is looking at the last question that you wrote on that survey. It is the what do you think? So we're in the Jamboard already, so we don't have to follow all these instructions, but I want all students to post your what do you think? What your response to the what do you think on Jamboard's pages 4 and 5. And to get to Jamboard pages 4 and 5, all you got to do is just go right here and go from 3. And actually, hopefully everybody is here. Just go from 3, and then here is page 4. There's page 5. Sticky notes, I think, will probably work the best. So I want every student to post your what do you think? And I'm down to less than 2 minutes of recording time, so let's pause here while students are posting. Thanks. All right, this is probably my final bit of instruction on the day. So I want you all to review everyone else's posting on the Jamboard. So go ahead and look at everybody's pages 4 and 5, or the Jamboard pages 4 and 5. And then for asynchronous time, I want you to come up with, and this is going to be difficult, I want you to come up with a list of things that you think you need to know about. And then here is what we can be doing in asynchronous time. Review the safety expectations. It's on this Google presentation. It happens to be the next slide. And then write down the list of things you need to know more about, and you can do that in your science notebook. And hopefully you all have your science notebook purchased and you have it with you, because that's the one thing that you needed to have is your science notebook. I think that's it for the day. If anyone's confused, shoot me an email. So anyways, there you go. Good luck. And hopefully you'll come up with a lot of things on your list of things that you need to know about. Tomorrow we're going to continue this, and we're going to start building arguments as to why the test tube is actually disappearing. All right, good luck. See you tomorrow.